Alright, so previously we have covered the first two key points in topic 1, and now let's have a look at key point 3, quadratic functions. Okay, first of all, a quadratic function has this form. Y equals ax squared plus bx plus c, where a is not 0. Otherwise, it could be a linear function, right? The graph is a parabola with the following properties. Make sure you are familiar with the properties of a quadratic function. First is concave up if a is greater than 0, and concave down if a is less than 0. So the sign of a determines its opening direction. Its axis of symmetry can be expressed as x equals negative b over 2a. Its vertex has x coordinate negative b over 2a. And of course, the y coordinate its vertex is found by substituting x equals negative b over 2a into the function. And actually, the y coordinate is this one. It's actually a ratio, right? So if you insert x equals negative b over 2a into that function, you will have a y coordinate of the vertex. And therefore, we know the vertex of this quadratic function has a coordinate negative b over 2a, 4ac minus b squared over 4a. That's the coordinate of the vertex, right? And of course, if a is greater than 0, the vertex is the minimum turning point, and if a is less than 0, then the vertex is the maximum turning point. So we'll talk about the concept of minimum, maximum, and turning point in our later lessons. And also, the quadratic function has a discriminant delta, which is defined as b squared minus 4ac. And the value of delta determines whether the graph will cut the axis 0 times, 1 time, or 2 times. If delta is greater than 0, the graph cuts the x-axis twice. And if delta equals 0, the graph touches the axis only once. And if delta is less than 0, graph does not cut the x-axis. Which also means when delta is greater than 0, the corresponding quadratic equation will have two different zeros. And when delta equals 0, you only have one zero, right? And when delta is less than 0, the corresponding quadratic equation will not have any real solution. Did you get that? Okay, any questions? No? Okay, problem. And actually, we similar to the different types of equations for lines, we have different forms for quadratic equations or quadratic functions as well, right? The equation we just mentioned is called general form, which is y equals ax squared plus bx plus c. Also, the quadratic function can be expressed in a factored form. If you can have its two zeros, for example, p and q, then the quadratic function can be expressed in this form. Y equals a leading factor a times x minus p times x minus q. So p and q here are the zeros of these functions, which are also its x-intercepts. And of course, if you express that in that way, we know the axis of symmetry, which is x-coordinate of the vertex, is the midpoint of p and q. Therefore, the axis of symmetry is x equals p plus q over 2. And of course, we could also express quadratic function in a vertex form. which is a times x minus h squared plus k. And if you can write quadratic function in a vertex form, you can read the coordinate of the vertex from this equation directly, which is hk. And of course, in this way, the axis of symmetry is x equals h, right? So these are the three different types of equations of a quadratic function. You finished? Okay, and next let's have a look at an example to check your understanding of quadratic function. So for the following function, can you state the coordinates of the vertex, the direction of opening, the min or max value of the function, if any, and then the number of x-intercepts? Okay, so how do you analyze this question? For the coordinates of the vertex, you could directly use the formula to find it, right? Note that this is in a standard form or general form, where we could let a equals -3, b equals -6, and c equals 9. That's the three parameters of quadratic function, right? So we know the x coordinate of the vertex is negative b over 2a, which is negative 6 over -6, therefore we have -1. And y coordinate is this expression, right? Just insert all the values here. 4 times -3 times c, 9, minus b squared over 4a. And this gives us 9 plus 3, which is 12, right? Therefore, we have the coordinate of the vertex is -1 and 12. Direction of opening, that depends on the value of a, right? We know a is less than 0, so we know it is opening down. Min or max value of the function. So we can sketch this graph because it's opening down, and we also know its vertex. Well, we don't know its relationship between we don't know the relationship between the function and x coordinate yet, right? But we do know its vertex coordinate. So that's its maximum point. Okay, so the function has a maximum value. Maximum value of this function is the y coordinate of the vertex, right? Which is simply 12. So how do you determine the number of x-intercepts? There are a number of ways you can do this, right? You could check delta. In this way, delta equals b squared minus 4ac, which is 36 minus 4 times -3 times 9, right? And this gives us 36 plus 12 times 9. Apparently this is a positive number. You don't have to calculate that because question only asks you to check the number of x-intercepts, right? When delta is greater than 0, we have two different x-intercepts, right? So we have two different x-intercepts. And there's another way you can do this. You can just compare the y-coordinate of the vertex. We know the vertex has coordinates -1 and 12. Also, the function is opening down, right? So -1, 12 is above the x-axis. So that's the relative position between this function and the x-axis. So there must be two different zeros. This is another way you can check the number of zeros of this function, or number of x-intercepts, right? Did you get it? You can choose either way. Alright, have a look at the solution here and let me know if you finish, okay? Finished? Okay, let's see the next example. Can you find an equation whose graph is a parabola with vertex 1, 2 and vertical axis of symmetry, such that the parabola passes through a point 3, 3? So this time you know information of the vertex, and we also know it's a parabola and it passes through 3, 3, right? So note that there are three types of equations we can use to express a parabola or quadratic function, right? So in this question we know it's vertex, so it's better to use the vertex form, right? So you could say we could let the equation be y equals, what is the vertex form? Vertex form of a quadratic equation, a quadratic function, is y equals a times x minus h squared plus k, right? This is a vertex form, right? So here we already know the x coordinate of the vertex, which is 1, and y coordinate is 2. So we can just directly say, let the equation be y equals a times x minus 1 squared plus 2, right? 1, 2 corresponds to the coordinates of the vertex. And we also know this parabola passes through this point. So that means we have one x equals 3, y also equals 3, because 3, 3 is on that equation, so it must satisfy that equation, right? And that means 3 equals a times 3 minus 1 squared plus 2. So in this way we can just solve a. So this means 4a plus 2 equals 3, which means a equals 1 over 4, and therefore the desired equation can be solved, which is y equals 1 over 4 times x minus 1 squared plus 2, right? And the question does not ask you to transfer this to a general form or other form, so you can just leave it there. This is called a vertex form, right? Any questions? Okay, let's have a look at another example. So this time it tells you that following the sketch of the graph of quadratic equation, a quadratic function, can you find the expression of such a quadratic function? This time we know the quadratic function crosses 3 points. Are you able to find the equation of this function? Also note that there are 3 types of different forms of equations we can use to express a quadratic function, right? So which one should you choose here? We don't know its vertex, we don't know the zeros, so we could only use the general form, right? Okay, so we could let the desired function be general form is y equals ax squared plus bx plus c, where a is not 0. This is a general form of a quadratic function, right? Note that there are 3 unknown parameters, a, b, c, you need to solve, right? So usually, if you have 3 unknown quantities, we need at least 3 equations. Do you have 3 equations here? Yes, we do, because all of the 3 points satisfy this equation, right? So we just insert them into that equation separately, then you have 3 equations, right? So we could see these points are all on the graph. So we have, well, first of all, when x equals -4, y equals -5. Well, that means 16 a minus 4b plus c equals y, which is -5, right? And then we also have one x equals -1, that's a minus b plus c equals 4. And also when x equals 1, we have a plus b plus c equals a -20. So basically you want to solve a system of 3 linear equations, right? Are you able to do this? Yeah, we should be able to do that. You could solve this equation by reducing the number of variables, right? Do you want me to show that to you? Okay, so we can basically label these 3 equations as number 1, 2, and 3, right? So first of all, apparently we can use equation number 3 subtracted by equation number 2. This will directly give us 2b equals -24. So we can solve b first, which is -12, right? So let's mark this as number 4. Then we can put number 4 into equation number 2. And this will give us a plus 12 plus c equals 4, right? Which means a plus c equals -8. Well, let's call this number 6. Oh, sorry. We also need another equation. We can insert number 4 into equation number 1 as well, right? And this will give us 16a plus 48 plus c equals -5, which means 16a plus c equals -53, right? So we can call this equation number 5 and number 6. So now we can use equation number 5 subtracted by equation number 6, and this will give us let's use equation number 6 minus equation number 5 because we don't like negative coefficient. So in this way we have 15a equals -45, and therefore we can solve a, which is -3, right? And let's call equation number 7. Then we could insert equation number 7 into equation number 6, and this will give us -3 plus c equals -8, and therefore c equals -5. So as long as you have a, b, and c, then we know the equation of this function, right? Therefore, you could conclude the desired function is y equals a, -3x squared, plus bx, which is -12x, plus c, which is -5. So this is a equation of the desired function, right? Okay, any questions? So the key is to choose appropriate equation type for solving the equation of the desired function. If you don't know anything, probably you should use the general form, right? Okay, now let's have a look at some other related concepts. Quadratic equations. A quadratic equation of the form ax squared plus bx plus c equals 0, where a is not 0, can be solved by either factorization, completing the square, or you can just directly use the quadratic formula, right? But before using the quadratic formula, please check the discriminant to see whether it's greater than 0, meaning it has two different roots, or delta equals 0, you have one root, and delta less than 0, you don't have any roots in the real number set. And discriminant of the quadratic equation is delta equals b squared minus 4ac. And you can also solve quadratic inequalities in either the form a squared plus bx plus c greater than or equal to 0, or ax squared plus bx plus c is greater than 0, where a is not 0. Usually you can sketch a graph of this function and find the interval that will satisfy this inequality, right? Or if you don't want to use a sketch of graph, you could also use sign diagram. But personally, I think it's quicker to use a sketch of the graph to check the intervals. Okay, let's have a look at some examples to illustrate quadratic equations and quadratic inequalities. First, let's try to solve the equation here. X squared minus 2x minus 9999 equals 0. Can you find the roots of this equation? Any ideas? We have just mentioned you can either factorize it or completing the square. Well, completing the square is actually another way to factorize it. Or you can directly use the quadratic formula, right? So, well, of course, for any quadratic function, you can just directly use the quadratic formula, right? So in this case, first let's calculate delta, which is b squared minus 4 times a times c. And this will give us 4 plus 4 times 9999. And 4 is a common factor, so put it in front, and then 1 plus 9999, right? And that'll give you 4 times 10,000. And then the root of this function can be given as 2a denominator, then negative b, which is 2, plus or negative square root of delta, which is 4 times 10,000, right? And this can be easily squared to 2 times 100 over 2. So there are two roots. The first one is 2 plus 200 over 2, This will give you 1, 0, 1. Or we have another solution, x equals 2 minus 2 times 200 over 2, which is negative 99, right? Did you get it? And of course, there usually are more than one way we can use to solve it. So let's have a look at another method. Remember, we can also solve it by completing the square. So note that we have a 2x here, right? So you can add a 1 here to have a x minus 1 square, right? Because if you expand x minus 1 square, you will have this expression, right? But we don't have a plus 1 in the original expression, so we need to add a negative 1 to compensate the plus 1, right? And then copy the rest of the solution, the equations. The original equation is equivalent to this one because they are exactly the same. And then that's equivalent to, first part can be expressed as x minus 1 squared. The later part can be expressed as 100 squared, right? Which equals 0. And then we can use the formula a squared minus b squared equals a plus b times a minus b to factorize that, right? And then we have two possible solutions. Therefore, x equals either negative 99 or the other solution is x equals positive 1, 0, 1, right? So you could choose either solution. Any questions? Okay, and then let's have a look at a quadratic inequality. So suppose we have an inequality like this. Can you find the solution of the inequality? That means find the interval of x that will satisfy this inequality. Are you able to do that? So usually we can sketch this graph and find the corresponding intervals, right? So first of all, usually we'll convert that to a general form, put everything on one side. For example, this is equivalent to 2x squared plus 11x minus 21 less than 0, right? So the left side is a quadratic function which is opening up. We need to check how many zeros are there to decide whether we have an interval that will make this function less than 0, right? We can easily factorize this to, well, by use cross product method. 2 can be factorized to 1 by 2. Negative 21 can be factorized to, for example, 7 by negative 3, right? And the cross product, ensure the cross product will give you the coefficient in the middle. So in this case, we have 14 minus 3, which is 11, which is exactly the coefficient in the middle, right? This is called cross product method to factorize a quadratic expression. So that's equivalent to x plus 7, that's x plus 7, and 2x minus 3 less than 0, right? Okay, so if you're not very confident about the result, just try to verify your result by expand it back to see if you can have the same expressions here. Okay, and now we know this is a quadratic function which is opening up, and it also has two zeros or two x-intercepts. The first one is negative 7, right? The second one is positive 3 over 2. Two zeros like this, it's opening up. We don't care about this vertex because we only want to find any interval such that the function is less than 0, right? Can you see that? So from the sketch of this graph, we can easily see the interval you are looking for is from this point exclusive all the way to the second 0 here. If x is between -7 and positive 3/2, then the function will be exactly less than 0, right? Therefore, we know the solution is x must be between -7 and 3/2, open interval, right? Or you could also use interval notation. You could also write it like this: x belongs to a open interval from 7 to 3/2. You can use either one. They are actually the same thing. Alright, so let's see one last example to wrap up this part, quadratic function. And here we have a number k. K is some real constant. For what value of k this inequality has the solution x belongs to the real number set. Okay, I'll give you some time to have a look at this question by yourself. Let me know if you finish or if you're stuck anywhere, and then we'll have a look at the solution together, okay? Alright, let's have a look at the solution together. Okay, so note that suppose k is a number. Let's treat k as a number. First of all, the left side is the expression of a quadratic equation, a quadratic function, right? We know if we let y equals -3x squared minus kx minus 9, then this is a quadratic function. A is less than 0, so we know it's opening down, right? If it's opening down, there are only 3 possibilities. It could either have 0, zeros, or 0 x-intercepts, or just 1 x-intercepts. Like this. It will touch the x-axis just once. Or it could also have 2 different x-intercepts, right? These are the only 3 possibilities. So the question says, no matter what x is, this function is always less than 0, right? So which case is the correct case? This is the only possible case, right? In this case, no matter what x is, that means as long as x belongs to the real number set, the function is always less than 0. Means no matter what x is, the whole function is under the x-axis, right? So we need to ensure there are no zeros. Then the solution to this inequality must be x belongs to the real number set, right? So we could say let's label it with star to facilitate our discussion. So star has the solution x belongs to real number set. This statement is equivalent to we do not have zeros, so no zeros for this quadratic function. And we already know no zeros for a quadratic function means the corresponding delta must be less than 0, right? So how do you calculate delta? Delta equals b squared, in that case k squared, minus 4 times a times c. Delta must be less than 0 to ensure there's no zeros for the corresponding function, right? And we can easily solve the inequality in terms of k, which means k squared minus 108 must be less than 0, right? And therefore k squared must be less than 108, which means can you solve this by yourself? If a number squared is less than a positive number, that means k must be between positive square root of that number and greater than negative square root of that number, right? Which is equivalent to k must be between 6 square root 3 and negative 6 square root 3. This is your solution. K must be within this interval to ensure the solution is the whole root number thing, right? Okay, have a look at the solution here. Let me know if you finish. Yeah, again, it checks your understanding of the quadratic functions. So as I said, for each type of function here, it's better to know all the properties, but the most important ones is the graph of that function, right? If you know the graph of that function, probably you'll know everything about that function, right? Okay, so this is a quadratic function. We can take a 5 minutes break, and after that, we'll have a look at the next topic, which is a power function, or general power function. Okay, I'll see you in 5 minutes.